section 12.4 is where we're going to be. Simplifying rational, not radical, but rational expressions. Okay, rational expressions, those are fractions. Okay, so we're going to be simplifying fractions, and that's going to involve a lot of the things that we've done thus far, especially this semester with this stuff. And when you're simplifying rational expressions, the instructions will read simplify and state the excluded values. Excluded values. So when you're doing that, it'll say simplify first and then say state the excluded values. What we want to do is we want to state the excluded values first. We want to do that before we simplify. Because sometimes if we do simplify, we lose part of the things that make excluded values. So we want to simplify last after we found the excluded values. Excluded values are numbers in them that make the denominator 0. We're dealing with fractions. They're going to have some variables in the denominator. What value for that variable would make the denominator equal 0? Because what's the only number we can never divide by? 0. So that's why we've got to find these excluded values, is what makes the denominator 0, because we cannot divide by 0. So we got to know what numbers to throw out, okay? Now, so let's look at some examples. I think that's the best way to get into this. So 15x squared over 35x. And we want to simplify that, but we also want to state the excluded values. Because there's a variable in the denominator, we know we'll have excluded values. If there's not a variable in the denominator, not an x or a y or anything other letter, then you don't have excluded values. The only time you have excluded values is if there's a letter in the bottom part of the fraction. Okay? Most all of the ones you'll see today have letters in the denominator. Okay, so we're going to have to deal with that the whole time. So when you're finding excluded values, I usually just abbreviate those EV for excluded value. You just take the denominator straight the way it is, and you set it equal to 0. And you're going to solve that equation. Okay? Sometimes that's going to be an easy one-step equation, just like this one is. How do we get x by itself? Divide by 35, we've got x by itself. What's 0 divided by 35? 0. The only excluded value we have for this problem is 0. Okay. Sometimes there might be an x squared. We might have to take a square root at some point, but we're just solving that equation. It's going to be an equation like we've solved before. Okay, so it's not going to be anything just entirely new for that part of this stuff. Okay. We ain't done that. We're not there yet. Okay. So excluded value first. Only use the denominator, set it equal to 0, solve it. That gets you your excluded value or values depending on the problem. Okay. The next thing is go back to the fraction and let's look at simplifying it. So when we look at that, what do we know about 15 and 35? They're both divisible by 5. How many times does 5 go into 15? 3 times. So 15 is really 5 times 3. And 35 is really 5 times 7, right? What does x squared mean? It means x times x, right? Yeah. And then an x on the bottom. Now let's look at that and try to dissect this to help us with bigger problems later on. This is a very, very simple problem. But if we think about this one in the same way we would think about the harder problems, I think it makes those harder ones easier. Anything that's multiplying together is called a factor, right? the factors of 12, we would say 3 and 4 are factors of 12 because they multiply together and be 12. Here we've got factors on the top. We got 5 is a factor, 3 is a factor, x is a factor, and this other x is another factor on the top. On the bottom, the factors are 5, 7, and x. What we want to do is cancel matching factors. Well, what matching factor do we have here? 5 is a matching factor, so we would cancel it out. This 5 on top cancels that 5 on the bottom. Do 3 and 7 match? No, so they're not going to cancel. This x and this x would cancel, right? Yep. This other x, it doesn't have one to cancel with down here, so it's going to stay. So things that are not canceled are still there. So our final answer then would be 3x over 7. Not that bad. Doesn't get in general, that is what we're doing all day. What do you do with the excluded value? The excluded value is a statement you just got to make. You got to say, oh, the excluded values for this problem are 0. It'll relate more to what we're going to do probably Monday. Okay. Well, it's not going to just always equal 0, but not too many of them are hard to solve. We'll get to that. Yes, this part over here is the simplified part. The excluded value part is just kind of its own thing. It has very little to do with this, but it does have something to do with it. You'll see as we do some examples, we'll see how they kind of can help each other out. Okay. All right, let's look at another example. Let's do 42 x to the 4th over 28 x squared. So we're going to find the excluded value first before we do any of the simplifying stuff. How do we find that? 28x squared equals 0. Take whatever's in the bottom, set it equal to 0. Now what? Divide by 28. 0 divided by 28. 0. Okay, so I'm just taking the denominator, setting it equal to 0, and then we're dividing by this number that's in front to get rid of it so that x squared is by itself. So x squared is equal to 0. How do I get plain x? Square root, right? Yep. We did that recently, right? Yep. Amazing. I taught you something you needed before you had to use it. Normally, we would put a plus or minus in here, but is there such a thing as plus or minus 0? No. No. So what's our only excluded value? 0. So that's our excluded value. That's kind of its own separate thing. Now, let's look at these two and think about simplifying that. So we want to look for 42 and 28. What do they have in common? Is that the biggest thing to have in common? 7 goes into both of them. So how many times does 7 go into 42? 6 times. How many times does 7 go into 28? 4. Do 6 and 4 have something in common? 2. So what's 7 times 2? 14. That would be the greatest common factor of 42 and 28. It's 14. So 42 has the greatest common factor of 14 and times 3. And then x to the 4th, we know is 4x's. So we're going to think it's 4x's written out there. And then 28 is 14 times 2, and then 2x's. What cancels out here in our factors? The 14s, obviously, they're the same. They're canceling each other out. And these 2 x's on the bottom cancel 2 of the x's up top. So what's left? 3x squared on top. What's on the bottom? Just a 2. We simplified a rational expression. No, it's not bad at all. Not a whole lot, but some. Definitely some. Let's look at one that's not just monomials on top and bottom. I'll kind of try to ease you into it. I won't drop you into the boiling water right away. I'll warm it up real slow, so you don't even know that you're getting cooked.
Oh my gosh.
Not ever heard that?
No.
All right, now, here's our rational expression. We want to first find the excluded value. So what do we do for the excluded value? Yeah, so take the bottom part, 10 parentheses, x plus 3, and set it equal to 0. There's a couple of different ways to solve this. Both get the same answer. You do it correctly. Okay, if you distribute first, you get 10x plus 30, right? And that's absolutely okay to do it that way. Could have divided by 10, yeah. Subtract 30. So 10x is equal to negative 30. And then divide by 10. So at some point, you've got to divide by 10. Negative. What's negative 30 divided by 10? Negative 3, right? So there's our excluded value. Okay. Now.
So they don't, I thought they had to like always equal 0.
Well, they start out equaling 0. Then when you solve it, it doesn't have to end up being 0. Okay? Because here's the reason negative 3 is the excluded value. If I put a negative 3 in right here, what's negative 3 plus 3? What's 10 times 0? What's the only number we can never divide by? Negative 3 puts a 0 down here. We can't do that. Ever. Okay? So that's why that's what the excluded value tells us about it. Okay? Now, next thing to do is look at your factors. Since, y'all remember us factoring back for about a month and a half, we did some factoring. These are already in factored form. It's like they pulled out a greatest common factor of x. And you got x times x plus 3. And then this one, they pulled out the greatest common factor of 10. You got 10 and x plus 3. What's the matching factor? X plus 3 matches this x plus 3. Just like on the previous problem, the 14 matched the 14, right? That was the matching factor, and they canceled each other out. The same thing happens here. X plus 3 matches x plus 3, so they cancel each other out.
Wow.
Yeah. They are. They are that easy. They're all that easy. Those. All right, let's look at this one then. Three parentheses x plus 8 over 12x plus 96. Okay. Again, I've turned the knob on the stove up just a little bit. Warm that water up a little bit more. What do we do first? Yeah, excluded value. Just go ahead and get that out of the way. Subtract 96, good. 12x is equal to negative 96. Divide by 12, that's good. And there's negative 8. So our excluded value for this is negative 8. Whoopee. We're not doing anything much with that right now. Okay, we're going to get to there.
But not today, right?
But we just got to find them today. We're not really going to do anything with them today. All right, now, the next thing to do is let's try to make this fraction look like the one from example C. Okay, the top part's already there.
Okay. Could you find two numbers like 112 and 96 and make it look like the
That'd be a good idea. What would that number be called?
Common, I don't know.
Something common, blank, common, blank. Greatest common factor. Absolutely. That's what we're looking for. What is the GCF of 12x and 96? 8 doesn't go into 12. 12 goes into 12, and 12 goes into 96 how many times? That's where that 8 coming from, right? So 12 parentheses. What's left in the parentheses? X plus 8. And then what can you do with the 3 and the 12? That's right. You're on the right track, because here 12 times x is 12x, 12 times 8.
That's great.
Wonderful, beautiful. And 3 and 12 reduces to 1 over 4. Makes you feel smart, doesn't it? Well, you get to use something that we learned how to do. And it actually has a reason for existing now. You have purpose. All right, let's look at this one. 2x plus 6 over 8x. Okay, so let's do the excluded value. This one's an easy excluded value. What do you set equal to 0? 8x, and then divide by 8, and we got 0. Okay, so easy excluded value on this one. Now, again, our idea here, what did we do on the last one? We only had to do it to the denominator, but we found that greatest common factor. So with this one, we're going to look at the numerator. What's the GCF of 2x and 6? 2. So we're going to pull a 2 out to the front. What's that leave in the parentheses? Good job. Because 2 times x is 2x and 2 times 3 is 6. That's why that's there. So if you struggled with factoring, I'm trying to get you a little extra help here, because you got to be able to factor to do this. 2 is the GCF of 2 and 6, right? So that's out here. What times 2 gets me 2x? X. What times 2 gets me 6? 3. That's where those are coming from. Now, the bottom part won't factor because it's not got addition or subtraction in it. So we just got to think, okay, it's 8 times x. What can you reduce?
Never mind.
Think about what's going on up top. We got how many factors on the top? Got a 2 and an x plus. If we distribute it, we're back to where we started. You could, but you're just working in a circle then.
That's a great question.
All right, so look at the top. We got factors 2, and the other factor is x plus 3. Does that make sense? 2 is multiplied times the factor x plus 3.
Could you do 8 times x plus 1?
No.
Why?
Because why would you add 1?
Never mind then.
Well, I mean, that's putting something in the problem that's not there.
That's not zero.
It's kind of like scripture. You don't add or take away from it. Okay?
Well,
So-
I'm off.
All right, now, this is 2 times something. This is 8 times something. That doesn't match that. So, does this factor match this factor?
No.
No. What about 2 and 8, though? They're both divisible by what? 2. So, we could reduce that by canceling the 2 out to be a 1, and the 8 becomes a 4. So, we end up with x plus 3 over 4x. This x here cannot cancel this x up here, because this x is tied to the plus 3. Things that are tied together with addition or subtraction can't cancel with things that are tied together with multiplication. Okay? So reducing the coefficients in the front, the numbers in front, is what we could do there to simplify our fraction. It's not always going to simplify real pretty, but we're looking for factors that they have in common. The factor that 2 and 8 had in common was 2. So that becomes a 1. 1 times x plus 3 is just x plus 3. And 2 goes into 8 4 times, so that's 4x. That's why I'm getting that.
So you just find what goes into the top.
The common factor, yeah, of the top and the bottom. Okay? Let's turn it up a little bit more. 20x over 2x plus 10. It's just similar, just putting the single term on the top this time. Okay? First thing we do,
Find the
EV, right? So they get our excluded value. 2x plus 10 equals 0. Subtract 10. Yeah, divide by 2, good. And x is -5. So our excluded value is -5. Whoopee. All right, now, next thing to do is look to see if you can factor. Top part's just 20x. Not anything I can do to get anything done with that. But the bottom part, I got 2x and 10. What do they have in common? GCF is 2. So the factorization of that bottom part is 2 times what? X plus 5. On the top, we got 20 times x. We normally just say 20x. Right. Because they're factors, they're multiplied. So 2 goes into itself 1 time, into 20 10 times. Yeah. Good job. 10x over x plus 5. All right. 4x squared plus 12x over 4x. Okay. Excluded value. This one's an easy excluded value. It'll take just a second to do it. 4x equals 0. Divide by 4. 0. Easy one, right? Now, the key to simplifying these rational expressions is knowing how to factor. And remember our rules of factoring. The first thing you always look for is the GCF. Then you count the terms. Okay? So what do we got on this one? 4 is in common between 4x squared and 12x.
Oh, 4x.
They got x in common too.
Yeah.
So the GCF of the top part is 4x. And that leaves you, what times 4x gives me 4x squared is x. What times 4x gives me 12x is 3. The bottom part, I'm not doing anything to. Now, what matches? 4x and 4x. X plus 3. What's technically on the bottom? 1. Do we have to write that? No. Is it wrong if you do? No. Okay. So really, this is x plus 3 over 1. I'll just write it x plus 3 because that's the way you're going to see it. Okay. Factoring, key. Let's go a little further. X squared plus 7x plus 10 over x squared plus 2x. Again, we're going to find the excluded value first. And how do we do that? Good job. Now, go ahead. What do you mean?
Didn't we do
Are they like terms? No, because that's x squared and the other one's a plain x. So we can't put them together.
it wasn't x squared?
Can't divide by x because what if x were 0?
So do you have to do what we did last week with all those little x's and?
Think about what are your options. That's a quadratic.
Why don't you just divide it?
Oh,
I can't divide by x.
can you do the perfect, oh my, you know, where we do the polynomials?
That's what I'm referring to. The first thing you always look for in a problem is what? GCF, you mean? GCF. What's the GCF of x squared and 2x? 1 what? 1x. Leaving you x plus 2. Remember, solving quadratics by factoring. If they're equal, you get them equal to 0, and then you try to factor. The first thing you always look for is a GCF. And then this one, you got x squared and 2x. They share an x. So that's why I'm pulling this x out to the front, and that leaves x plus 2 in parentheses. Now, the next step in solving by factoring was to do what with each factor? Set it equal to what? 0. Each factor gets set to 0. The first one, x equals 0, I don't have anything to do. It's done. X equals 0. That's one of our answers. What do I have to do on the second one? Yeah. Yeah. There are two numbers that x cannot be. X can't be 0, and x can't be -2. Okay. Because if I put a 0 in for x here, I'd get 0 squared plus 2 times 0, which is 0 plus 0, which is 0, and I can't divide by 0. Okay? And here, if I put a -2 in, -2 squared is 4, plus 2 times -2 is -4. What's 4 plus -4? 0. Okay? So those are the numbers that don't work. Now, the next thing to do is go to your fraction. And the wonderful thing is, we've already factored the denominator. I don't have to do it again. I already know that it factors to be x times x plus 2. Because I used factoring to solve it. Bless you. All right. Now, how do I factor the numerator? Okay, I look for a GCF first. There's not one. There's 3 terms, so I do X method for that. What goes on the top? 10. 1 times 10 is 10. 7 goes in the bottom. What multiplies to be 10 and adds to be 7? 2 and 5, or 5 and 2. It doesn't matter what order you put them in there. Now, because there's nothing in front of x squared, that allows me to go straight to my factors, x plus 5 and x plus 2. Because they what? They match. Matching factors cancel. That's it. Because this is an addition here, so you can't cancel parts. Okay. Factoring by X method there because it had 3 terms. Let's do this. So we had x squared plus 7x plus 12 over x squared plus 6x plus 8. We got to find the excluded value, so I'm setting x squared plus 6x plus 8 equal to 0. Now, that's a quadratic, no doubt. What are our options for solving that? No, that's not an option.
B
We could do
squared plus -4 times
quadratic formula would be an option, but because I'm simplifying radicals, I'm going to end up having to do what to everything? We'll have to factor everything. So I want to use factoring to solve that because I'm going to have to factor it anyway. Whether I use quadratic formula to get the excluded value or not, when I go to simplify, I'm going to have to factor anyway. So I'm going to solve it by factoring. So that's got 3 terms, 1, 2, 3. So I'm going to use the X method. Multiply to be 8, add to be 6. 4 times 2. So since there's nothing in front of x squared, I can go straight to my factors, x plus 4, x plus 2. What do I do with each of those? Set them equal to 0. Good. Pretty easy to solve from there. Just subtract 4, -4 is one excluded value. -2 is the other. Right, I've already got the bottom part factored, so I don't have to do it again. It's x plus 4 times x plus 2. I hope that one of those factors shows up in the numerator so that I can cancel it out. So I'm going to factor the numerator. Multiply to be 12, add to be 7. 3 times 4 is 12. 3 plus 4 is 7. X plus 3, x plus 4. What cancels? X plus 3 divided by x plus 2. All right, so factoring is going to be key. Say we had 2x squared plus 3x minus 5 over x squared minus 25. Okay, so let's get our excluded value. Let's do that first. There are a couple of ways to solve this. What method do I want to try to use to help me out later on? Factoring. What do we know about x squared minus 25? 25 is a perfect square. True. That's important. Is there a GCF across those two terms? No. There's two terms though. What was the method for factoring things that had two terms? Difference of squares. What squared gets you to 25? 5. So what are the factors that go with that? Good job. Because it's a difference of squares, it always factors as x plus whatever squared gets you 25 and x minus whatever squared gets you that. Well, it is. What's positive 5 times negative 5?
Oh.
It is the negative 25. Yes, that's true. It does have to be that. Now, what do we do with those? Set them equal to 0 to get this part. And yeah, when we go to simplify, we're going to put them on the bottom. So there's -5 and +5 as our excluded values. Now, going to simplify this, we got x plus 5, x minus 5 on the bottom. The numerator, it's a trinomial. Is there a GCF amongst those three terms?
No.
No. What method do I use? X method. What goes in the top? -10. 2 times -5 is -10. 3 in the bottom. 5 and -2. Now here's the kicker. Can I put x plus 5 and x minus 2? No. Why not? Yeah, that 2 in front tells me I can't go straight to x plus 5 and x minus 2. I've got to do some grouping before I do that. So I would have 2x squared minus 2x plus 5x minus 5. And I would group that. What's the GCF of 2x squared and -2x? 2x. What would that leave in parentheses? Okay. And then the GCF of those two? 5, leaving x minus 1. So the factored form for the numerator is 2x plus 5 times x minus 1. One factor is the matching parentheses. The other factors and stuff in front. Oh, so nothing matches. Does it simplify? No. But I want to see this factored form as proof that it doesn't. Okay? Sometimes fractions don't reduce, right? Like 7 over 12 doesn't reduce, right? It's a fraction that doesn't reduce. This is a polynomial fraction that just doesn't reduce. But we had to do all of the checking that's involved for trying to reduce it, just like we would if it was something like 35 over 44. Those are both composite numbers. We would think it would simplify some, but it doesn't. Same thing here. These are both polynomials that have factors, but nothing canceled out. So this thing right here is our final answer with nothing canceled out. Sometimes they don't simplify, and that's okay. If you did your factoring correct, that's okay. If they don't simplify because you made a mistake in factoring, you're going to miss that one. You gotta make sure you're factoring correctly. All right, let's get to this one. What are we on here? Okay. All right. 3x cubed minus 27x over 9x squared minus 27x. Okay. This one and one more, and we're done, okay? I know y'all getting tired. Fifth block's tough. What do we do first?
The 3x cubed.
That is 3x cubed, yes, ma'am. 3x cubed minus 27x. And on the bottom, we got 9x squared minus 27x. All right, so let's get our EV. So we set 9x squared minus 27x equal to 0. What do we do from there? Is it a difference of squares? Is that where we go first? What should we always look for first? What is the GCF? 3 goes into 9, 3 goes into 27, but 9's bigger, right? And it goes into both of them. So I'm going to pull out a 9 and what else? They both got an x. So I'm pulling out a 9x. What's that leave in the parentheses? Okay, x minus 3. Good job. What do I do with each of those factors then? Equal them to 0. Okay. Pretty easy solve there. Divide by 9. X is 0. Add 3. And 3 is our other excluded value. The beautiful thing is we already have the factored form for the denominator, 9x and x minus 3. We're just borrowing that from where we found our excluded value. Let's look at the numerator. 3 is a common factor. What else is common? They both got x, right? I'm going to pull out a 3x. What's left in the parentheses then? Notice I didn't write it there on this fraction because there's something else I can do. What can I do? There's no more 27. I've got 3x times x squared minus 9. What does x squared minus 9 do? 9's a perfect square, isn't it? So isn't x squared minus 9 a difference of squares? And it factors. We got 3x, x plus 3, x minus 3. Those are the factors that make up x squared minus 9. What cancels? X minus 3 cancels. Perfect. How do they simplify? What's it? 1/3. Right. The x's cancel each other, and 3 over 9 is 1/3. So we end up with 1 on the top, 3 in the bottom. What's the final answer here? Good. Well, it's technically there, but what's 1 times x plus 3 going to do? It's just going to be the same thing. So if you wrote it like that, that's right. If you write it like this, that's right. I'm good with either way. Okay. All right. One more. Show you a little tricky one here. But it's short and easy. But it's got a little trick to it. So obviously we're going to find our excluded value first. 4 minus x equals 0. That's a pretty easy solve. Negative x equals -4. Divide by -1. X can't be 4. Or, the excluded value is 4. Now, yeah, they're swapped around. They look really, really similar, but they're not exactly the same. On the top part, what sign is x? Is it positive or negative? And the 4 is okay, but on the bottom, the 4 is, and the x is okay. So they're opposite signs on each of the pieces. Can't do that because then you're getting parts of things that are added and subtracted together. You can't cancel that. Let's think about how can we make the bottom part have a positive x and a -4 like the top part does. Ooh, y'all hear what she said? She said divide by -1. If you divide something by -1, what happens to it? It changes the sign of it, right? So if I factor a -1 out of the bottom, that's the same thing as dividing by it, right? That's what we do when we factor. So if I pull a -1 out of it, that'll change the sign of the 4 to -4. And then change the sign of the x to positive x. And on the top, we got x minus 4. This part right here, can we rearrange that? Yeah, we can rewrite it because it's now addition. Addition is commutative, meaning you can do this and it's still the same thing. If I do that, I'll have x minus 4 on top, -1 parentheses, x plus -4, or that's the same thing as x minus 4. And then now the x minus 4s cancel each other out. 1 over -1, which is -1. Because if everything cancels out on the top, it's a 1 left over. There's a -1 here, so 1 divided by -1 is -1. So this ugly thing here turns into -1. But the key is that factoring out the negative. Okay? The key is factoring out the negative. Here's practice for today. The front side stays pretty easy. You get down to about number 17 before they get really a little tougher. Okay. But only 20 of them.